Hello Year 7, this is the second lesson in the chemical reactions topic. Please pause the video and complete the Do Now in your exercise book. On the next slide are the answers to your Do Now. Please mark the ones in your book and correct any that may be wrong. The title for today's lesson is Molecules and Compounds. Please write this in your book. Last lesson we looked at what an atom is. An atom is the smallest part of any substance. They make up everything. Then we looked at elements. Elements are made of only one type of atom, and they are all listed on the periodic table you can find in your handbook next to the red page. We're going to watch a YouTube video.
Everything in our world, all matter, is made of tiny particles called atoms. This can contains rows of aluminium atoms. Atoms are extremely small, far too small to see with the naked eye. Aluminium is an element. An element is a simple, single material which cannot be broken up into a simpler material. The atoms in an element are all exactly the same. Each element has its unique chemical symbol, made up of one or two letters. No two elements have the same name or symbol. If there are two letters in the symbol, the first is a capital letter, while the second is a lowercase letter. Al is the chemical symbol for aluminium. There are more aluminium atoms in this ring pub than there are grains of sand on all the beaches in the UK. The charcoal in this barbecue is made of carbon atoms. Carbon is also an element, and its chemical symbol is C. Alex's earring is made of gold. Gold is yet another element. Its chemical symbol is Au, not G, as you might expect. Au are the first two letters of the Latin word for gold, aurum. There are over 100 different elements on planet Earth. Sometimes atoms can join together to form molecules. Many common gases, such as the oxygen and nitrogen in the air, are examples of atoms that exist as a molecule made up of more than one atom of the same element. Every element and molecule has a chemical formula which shows how many atoms it has. Chlorine is used to make bleach, found in many disinfectants. Chlorine is another example of a molecule made up of two atoms. Most of us are familiar with the distinctive smell of chlorine from the disinfectants in swimming pools.
Thank you for watching that video, Year 7. Okay, so what is a molecule? As you saw in that video, a molecule is a group of two or more atoms that are bonded together. They can be multiple atoms of the same element, i.e. a molecule of an element, and that's like the oxygen molecule and the nitrogen molecule you were shown in that video. Or they can be atoms of different elements, and this is called a molecule of a compound. This includes things like water that contain hydrogen and oxygen atoms. So let's look at molecules of elements. Some molecules, like metals, contain huge numbers of atoms, all exactly the same. Others only contain one atom, while some contain two. Those are known as diatomic molecules, and this includes oxygen, nitrogen, hydrogen, and chlorine. Molecules of compounds. All compounds contain at least two different types of atom. Some contain many atoms like this table salt, while others only contain a few. Here are some examples of compounds. This diagram shows molecules of the compound water, which is given the symbol H2O. Each molecule contains two hydrogen atoms, shown by the white circles, and one oxygen atom, shown by the red circle, and these are bonded together. Here is another example. This one shows molecules of the compound carbon dioxide. Each molecule contains two oxygen atoms, shown by the red circles, and one carbon atom, shown by the black circle. Again, these are bonded together. Here is another video to watch.
Some compounds contain hundreds or even thousands of atoms chemically joined together. They form huge molecules. Plastic, like this inflatable chair that Liana's blowing up, is a good example of this type of compound. The air that's blown into the chair is a mixture of atoms of different gases. The air is mainly oxygen and nitrogen, but also has other gases, including carbon dioxide, water vapour, neon and argon. These are the chemical symbols. All these different gases can be classified as atoms or molecules. Argon and neon on the left exist as single atoms, whilst the other gases are molecules of more than one atom. But these atoms and molecules, as we've seen, can also be classified as elements and compounds. Even though nitrogen and oxygen, now on the left, are molecules made up of two atoms, they are two atoms of the same type, and therefore, like argon and neon, they're elements. Whereas the water vapour and carbon dioxide molecules on the right are made up of two different types of atoms, chemically joined together, and they are compounds.
Okay, following those videos, can you have a go at answering this question? Which of the following diagrams represents one or more compounds? Have a go at drawing these diagrams into your book and putting your answer. Pause the video here while you do that. The answer was 3. Both A and D represent one or more compounds. In A, we have a compound that is made up of a white atom bonded to a black atom, and in D we have two different compounds, one containing one atom of the white element and one atom of the black element, whilst the other compound contains two atoms of the black element and one atom of the white element. Now answer this question. Which of the following diagrams represents more than one substance this time? Pause the video and have another go. The answer to this question is 4. Both B and D represent more than one substance. In A, they are all the same compound. In B, we have different atoms. In C, they are all the same molecule of an element. and in D we have 2 different types of compound. Each element on the periodic table has its own symbol, and if you look back at last lesson we looked at the key that shows you where to find these. Every element's name or symbol starts with a capital letter, and then any letters that follow that are lowercase. So you would write my name as Fisher, capital F, lowercase I, S, H, E, R. In the same way we would write iron as Fe, capital F, lowercase e. If there is a small number in a formula, then it tells you how many of the element before there is. We write the small number at the bottom. Here are 2 examples for water and carbon dioxide. How would you write chlorine? Look its symbol up on the periodic table. It is diatomic, so what else would you need to include? Pause the video while you look this up on the periodic table and write it in your books. Here is the answer. C, capital, lowercase l, and then a small 2, because it's diatomic, which means there are 2 atoms joined together. Can you have a go at writing the formula for ammonia now? I'm going to tell you that there is 1 nitrogen atom and 3 hydrogen atoms in every molecule of ammonia. Pause the video and have a go. Here's the answer for the formula for ammonia. Capital N, capital H because it's a different element, and then a small number 3 because there's 3 hydrogen atoms. If there are letters in brackets, we have to times everything in the bracket by the number after it. Here is magnesium hydroxide. You'll notice that the OH is in brackets with a number 2 after it. So it can be written like this. We just write the OH twice. This means there is 1 magnesium atom, 2 oxygen atoms, and 2 hydrogen atoms. The diagram on the right shows a molecule made up of 3 atoms. In your books, write down which chemical formula should be used to represent the molecule. Pause the video while you do this. Here is the answer. SO2. It doesn't matter which order the atoms are bonded together, we group them like this to make the formula easier to write. Please pause the video and draw the diagrams on the left in your books. Then have a go at matching them to the correct formula. Once you have finished, play the video again and you can see the answers. I would like this work uploaded to Teams please so that I can see it. Here are the answers. Thank you for watching this video. Please go and upload that work to Teams and I will see you next lesson. Bye!